The Liberty Ship. How America Built One Ship Every Day, Part 1. The Crisis at Sea. In the autumn of 1939, Europe descended into chaos. Nazi Germany, under Adolf Hitler's leadership, had invaded Poland and set its armies in motion across the continent. Within months, the Wehrmacht had swept through France, Belgium, and the Netherlands. By the summer of 1940, France had surrendered. Britain stood alone against the Nazi war machine. The British people faced a predicament more terrifying than invasion itself. Great Britain is an island nation, and islands survive only through maritime trade. The country possessed vast industrial capacity and a resilient population, but it lacked raw materials. Iron ore came from Scandinavia. Petroleum came from distant oil fields. Rubber, tin, copper, and bauxite came from colonial territories and allies scattered across the globe. Every essential commodity required to fight a modern war had to arrive by sea. The Royal Navy was still a formidable force, one of the world's most powerful maritime establishments. But the Admiralty faced an opponent that did not engage in conventional naval battles. The German Navy's strategy was not to defeat the Royal Navy directly. Instead, it sought to strangle Britain economically by cutting the lifelines that supplied the island nation. Germany deployed a new weapon with devastating effectiveness: the U-boat. These submarines operated in coordinated wolf packs, hunting merchant vessels in the Atlantic Ocean. A single merchant ship, traveling unescorted, could be sunk in minutes. The U-boats surfaced quickly, fired their torpedoes, and vanished beneath the waves before help could arrive. The statistics became increasingly alarming. In the early months of the war, German submarines and surface raiders sank merchant vessels at a rate that threatened Britain's survival. By 1941, the British merchant fleet was being destroyed faster than British shipyards could replace it. Every month, hundreds of thousands of tons of shipping capacity went to the bottom of the Atlantic. The cargoes of grain, fuel, and war materials vanished with the ships. British civilians faced the prospect of starvation. British industry faced fuel shortages that would cripple military production. The situation was so dire that some members of the British War Cabinet questioned whether the nation could survive. The loss rate seemed unsustainable. No matter how fast British yards built replacement ships, German submarines sank them faster. The mathematics were cruel and unforgiving. At the current rate of loss, Britain would have zero merchant shipping capacity within 2 years. The country would suffocate, not from military defeat, but from economic asphyxiation. Winston Churchill, who had become Prime Minister in May 1940, understood the existential nature of the crisis. He sent representatives to the United States with a desperate request. Britain needed ships, not a few dozen or even a few hundred. Britain needed thousands of merchant vessels to replace those being lost to German attacks. The British government proposed a radical solution. The United States should build these ships. The request faced an enormous obstacle. The United States was not at war. It was officially neutral, bound by neutrality laws that severely restricted commerce with belligerents. American public opinion was divided. Many Americans had no desire to become entangled in a European war that seemed distant and irrelevant to American security. American isolationism was a powerful political force in 1940 and 1941. Yet President Franklin D. Roosevelt understood something that many Americans did not. He recognized that American security was intimately connected to Britain's survival. If Nazi Germany conquered Britain, it would dominate Europe and potentially threaten American interests directly. Roosevelt began a careful process of building political support for aid to Britain while remaining technically within the bounds of American neutrality. The result was Lend-Lease, a program authorized by Congress in March 1941. Under Lend-Lease, the United States could manufacture weapons, aircraft, and supplies and lease or loan them to Britain and other nations fighting Nazi Germany. The British could receive American military equipment without violating American neutrality law. It was a legal fiction, but a necessary one. In practice, Lend-Lease meant that American industry would begin producing supplies for British use. Merchant ships fell squarely within the scope of Lend-Lease. The British submitted specifications for what they needed: cargo vessels that could carry supplies across the Atlantic, despite German opposition. They offered designs based on a proven concept. The British merchant marine had been using similar designs for decades, going back even further to a Swedish design from 1879. The design was not revolutionary. It was not built for speed or elegance. It was built for cargo capacity and simplicity of construction. The British design emphasized practical, straightforward construction. The ship would be approximately 440 feet in length, with a beam of 57 feet. It would have a gross tonnage around 7,000 tons and a deadweight capacity of 10,000 tons. It would be powered by triple expansion steam engines, a technology that was reliable, proven, and understood by American manufacturers. The engines would consume coal or heavy fuel oil. Top speed would be approximately 11 knots, respectable for a cargo vessel, though slow by warship standards. American shipyard engineers examined the British designs and saw room for improvement. The Maritime Commission of the United States, which coordinated civilian ship construction, decided to adapt the British concept for American production methods. American engineers understood manufacturing techniques, assembly line production, and industrial efficiency in ways that many traditional shipbuilders did not. The fundamental question facing American shipbuilders was one of capacity. In 1941, American merchant shipbuilding was at its lowest levels since before the First World War. The industry had contracted during the prosperous 1920s and 1930s, when merchant shipping seemed less critical to American defense. Shipyards that had constructed hundreds of vessels during the First World War were now working at a fraction of capacity. Some had shifted to other industries or closed entirely. The largest American shipyards were equipped with traditional riveted construction methods. Workers would fasten metal plates together using millions of rivets, hammering them in place through intensive manual labor. Riveting was labor-intensive, expensive, and required highly skilled workers. A single ship might require hundreds of thousands of rivets, and each one had to be installed correctly, or the hull would leak or become structurally unsound. Naval shipbuilders like Newport News Shipbuilding and Dry Dock Company could build warships using these traditional methods. But warships were different from merchant vessels. Warships had to be armored, heavily armed, and capable of sustained high speeds. They required the expertise of the finest craftsmen. Warships could take years to build, because no expense could be spared in their construction. Merchant vessels, by contrast, were cargo haulers. They did not need to be fast or maneuverable. They needed to be reliable, reasonably economical to operate, and quick to build. The British design understood this fundamental truth. The Americans would push this principle even further. American industry in 1941 was poised on the edge of total mobilization for war. Although the United States would not officially enter the war until December 1941, after the Japanese attack on Pearl Harbor, the foundation for industrial transformation was already being laid. The Lend-Lease program was pumping American resources into British coffers. American factories were beginning retooling for military production. The merchant ship program fit perfectly into this larger transformation. Here was something that could be built quickly, built in large numbers, and built by American workers. It would require innovation in production methods, but American manufacturers had pioneered assembly line production. They had transformed manufacturing from a craft into an industrial process. The question was whether they could apply these principles to shipbuilding. The first Liberty ships ordered under the Lend-Lease program would soon be under construction in American yards. These vessels would carry names of American patriots and heroes. They would carry cargoes of ammunition, fuel, food, and supplies across the Atlantic, through waters prowled by German submarines. Many would not survive the journey. Many would rest on the bottom of the Atlantic Ocean. But first, they had to be built. And the challenge of building them, of constructing thousands of ships in a matter of years, when American shipbuilding capacity seemed wholly inadequate to the task, would drive innovations that transformed not just shipbuilding, but American manufacturing itself. The crisis was real. The stakes were survival. Britain was running out of time, and America would have to respond with speed and ingenuity that seemed almost impossible. The ships being planned in American offices in 1941 would become central to whether the Allies could sustain their fight against Nazi Germany. Everything depended on whether American industry could rise to an unprecedented challenge. Part 2. Innovation at speed. The British design that arrived in American shipyards in 1941 was, in many respects, anachronistic. It bore the mark of its Swedish origins from 1879, more than 60 years in the past. The hull lines were utilitarian and ungraceful. The superstructure was functional rather than refined. The engines were simple, reliable steam plants that had proven themselves across decades of merchant service. The British designers had deliberately chosen proven technology over innovation. In wartime, reliability mattered more than novelty. American engineers at the Maritime Commission examined these designs with a critical eye. They recognized the fundamental soundness of the concept, but saw opportunities for improvement. The Americans would not attempt to revolutionize the basic design. Instead, they would revolutionize how the ship would be built. The Maritime Commission made a crucial decision. The new American ships would be welded, not riveted. This choice was radical and controversial. Riveting was the traditional method of shipbuilding. It was how ships had been constructed for generations. Experienced shipbuilders understood riveting. The skilled workers who could properly rivet a hull were already employed in the best yards. There was an entire culture and tradition around riveted construction. Welding represented something entirely different. It was a relatively new technology, still perfected, not fully trusted by the maritime establishment. Many experienced shipbuilders believed that welded hulls were inferior to riveted ones. Welds could be defective. A poor weld might fail under stress. The properties of the surrounding steel were changed by the heat of welding. There were legitimate technical concerns about whether a welded merchant ship would be as seaworthy and durable as a riveted vessel. But the economics of welding were compelling. Riveting was expensive. It required thousands of workers performing highly specialized labor. Each rivet had to be heated, inserted through aligned holes in overlapping plates, and then hammered in place. 2 workers worked as a team, one holding a bucking bar on the inside of the hull, while another hammered from the outside. The process was slow, labor-intensive, and accounted for approximately 1/3 of all ship construction costs. Welding could be done much faster. A welder could seal 2 plates together with a continuous bead of molten metal, creating a joint that was, in theory, as strong as the plates themselves. Welding required less time than riveting and required less skilled labor. A person with no prior experience could be trained to become a productive welder within a week. A riveter required months of apprenticeship to develop proficiency. The decision to weld meant that the American yards would need to develop expertise in welding that simply did not exist in the maritime industry. The American Society of Naval Architects and Marine Engineers was skeptical, But the Maritime Commission pressed forward. Speed was more important than comfort with tradition. The first Liberty ships would require approximately 50 miles of welding, 50 miles of continuous seams, each one critical to the integrity of the hull. The challenge was staggering. American welders would need to master a new technology while simultaneously producing ships at unprecedented rates. The second major innovation was prefabrication. Rather than building a ship from the keel up in a traditional sequence, the American yards would construct the ship in sections. Different sections of the vessel would be built in different areas of the yard, sometimes even in different buildings. A section of the double bottom might be constructed in one location, a deckhouse in another. The bow section, stern section, and midship sections would be built separately. Complete assemblies would be fabricated, turbo generators, ventilation systems, piping runs, and installed as units rather than being assembled piece by piece. These prefabricated sections would then be transported to the main building ways. Some shipyards used railroad flat cars to move enormous hull sections. Others used cranes and sophisticated transport systems. The sections would be positioned and then welded together in a coordinated sequence. What had previously been a linear, sequential process, keel laid, frames erected, plates riveted on, superstructure built, became a parallel process with multiple sections advancing simultaneously. This prefabrication approach was borrowed directly from automobile manufacturing. American automakers had pioneered assembly line production decades earlier. Henry Ford had transformed automobile manufacturing from a craft to an industrial process. The same principles could be applied to ships. Different workers would perform different tasks in different locations, and the product would come together through orchestrated movement and assembly. The third major innovation was the assembly line itself, adapted to shipbuilding. In traditional shipbuilding, workers remained largely stationary, and the ship was built around them. In the new Liberty shipyards, materials and partially completed sections would move toward the workers on a coordinated schedule. Materials would flow through the yards in carefully planned sequences. Every movement was designed to eliminate wasted motion and redundancy. The Maritime Commission issued a classification system for the new design, EC2SC1. The letters and numbers conveyed essential information to maritime professionals. EC stood for Emergency Cargo Vessel, a designation that acknowledged this ship's origin in wartime necessity. The 2 indicated the cargo capacity, between 400 and 450 feet in length. The S specified steam engines rather than diesel. The C1 indicated the design variant within the EC2 class. It was utilitarian nomenclature for a utilitarian design. The first Liberty ship, the SS Patrick Henry, was built at the Bethlehem Fairfield Shipyard in Baltimore, Maryland. The Patrick Henry was named after the American patriot who had declared, "Give me liberty or give me death," during the Revolutionary War. The choice was deliberate and symbolic, a new ship for a new war, named after a voice from America's founding. The keel of the Patrick Henry was laid on September 27, 1940. The ship took 150 days to build. 150 days from keel laying to launch. By the standards of wartime shipbuilding that would soon follow, this seemed remarkably slow. But in 1940, 150 days was considered an acceptable construction time for a cargo vessel. The Patrick Henry was an achievement, a demonstration that the new methods could work. President Franklin D. Roosevelt attended the launch ceremony on September 27, 1941, exactly 1 year after the keel laying. It was a ceremonial occasion, a moment to celebrate American industrial capability. The president stood to witness the christening, the moment when the new ship would slide into the water for the first time. The Patrick Henry proved that the design was viable and that American yards could build it. But the Patrick Henry was only the beginning. The methods used to build it would need to be refined, accelerated, and scaled up across multiple yards. The goal was not merely to build merchant ships. The goal was to build them in unprecedented numbers and at unprecedented speed. 150 days per ship was still too slow to match the rate at which German submarines were destroying British merchant vessels. The prefabrication methods pioneered in the Patrick Henry's construction would be pushed further and systematized in subsequent yards. The welding techniques would be refined. The assembly line coordination would become increasingly sophisticated. American yards would begin competing with each other, each trying to streamline the process further than the next. The workforce would need to be transformed as well. Traditional shipbuilding was a male-dominated craft, with workers who had learned their skills through years of apprenticeship. The new Liberty shipyards would draw on a much broader labor pool. Women entered shipyards for the first time in significant numbers. Recent immigrants, retirees, and people from all walks of American life came to work in the yards. The traditional barriers and hierarchies of craft production would fall away in the face of urgent production demands. The prefabrication approach solved another critical problem. It did not require the massive crane capacity that traditional sequential shipbuilding demanded. Traditional yards needed enormous cranes to move heavy hull sections and ship components into place. These cranes were expensive and took time to install. Prefabrication yards could use smaller, more portable equipment and still move material efficiently. The decision to weld rather than rivet also meant that yards did not need as many riveting gangs and rivet heaters. These were specialized workers whose skills were in high demand. By eliminating riveting, the yards could reduce their dependence on this scarce labor resource and instead train general welders who could be drawn from a broader labor pool. The British design had been chosen partly because it was simple and proven, but American engineering ingenuity would enhance it without losing its essential character. The hull lines would be adjusted slightly for more efficient construction. The engines would be sourced from American suppliers. The electrical systems, pumps, and other machinery would be standardized to American specifications. The Liberty ship would be a hybrid, a British design built using American manufacturing methods by American workers for the purpose of supplying Britain in its hour of need. By late 1941, multiple American shipyards were preparing to begin Liberty ship construction. Bethlehem, Fairfield, and Baltimore had proven the concept. The Permanente Metals Corporation in Richmond, California was gearing up for production. The Federal Shipbuilding and Dry Dock Company in Kearny, New Jersey was being transformed. Dozens of other yards, large and small, were being retrofitted and reorganized. The stage was being set for an unprecedented transformation of American shipbuilding. The foundation had been laid. The designs were finalized. The yards were preparing. The workforce was being mobilized. In 1941, as America prepared for total war following the Japanese attack on Pearl Harbor in December, American shipyards stood ready to implement a revolution in how ships would be built. What had seemed impossible, producing merchant ships at scale, was about to become possible through innovation, determination, and the power of American industrial capacity. Part 3. The impossible acceleration. In 1942, American shipyards began building Liberty ships in earnest. The first year of production was experimental and uncertain. The Patrick Henry had proven the concept, but could the design be repeated? Could production rates be increased? Could the methods be refined? The answers came slowly at first, then with increasing confidence. By the end of 1942, the American shipbuilding industry had achieved something extraordinary. The Maritime Commission set an official target: 1 ship per day. The goal was not merely optimistic. Many in the shipbuilding industry considered it to be physically impossible. The best American shipyards had never produced cargo vessels at such a rate. The logistics alone seemed staggering: the steel procurement, the component manufacturing, the coordination of countless suppliers, the scheduling of thousands of workers, the movement of massive hull sections. The complexity appeared insurmountable. Yet the Maritime Commission was serious. The ships were needed desperately. Every month that passed meant more merchant vessels sunk by German submarines. Every tonnage of shipping lost meant less ammunition reaching British forces, less fuel for British factories, less food for British civilians. The target of 1 ship per day was not arbitrary. It was a necessary response to an existential crisis. In the summer of 1942, a competitive spirit began to infect the shipyards. The Maritime Commission recognized that competition could drive innovation and acceleration. Different yards began trying to outdo each other, not through official competition, but through the natural human desire to excel and demonstrate capability. The Permanente Metals Corporation operated a shipyard in Richmond, California. In July 1942, Permanente launched a Liberty ship in just 23 days. It was a stunning achievement. The yard had taken a complete, functional merchant vessel from keel laying to launch in less than a month. The speed seemed almost miraculous. Word of the achievement spread through the shipbuilding industry. The competing yard was the Richmond Shipbuilding Company, also located in Richmond, California. Richmond Shipbuilding responded to Permanente's record with their own effort. In August 1942, they launched a Liberty ship in 21 days. The competition was escalating. Permanente returned to the challenge. In October 1942, they launched another Liberty ship, this time in just 13 days. 13 days from keel laying to launch, from the moment the first piece of steel was positioned on the building, ways to the moment the completed ship was christened and released into the water. The records being set were becoming increasingly difficult to sustain, yet the yards continued pushing. Richmond Shipbuilding made another attempt. In November 1942, they achieved something that seemed to defy belief. They constructed a Liberty ship in 7 days, 7 days from keel laying to launch. The ship was the SS Robert E. Peary, named after the Arctic explorer. The construction of the SS Robert E. Peary became the stuff of legend. On November 8, 1942, at 12:01 in the morning, the keel was laid. The ship consisted of approximately 250,000 individual parts. The total weight was approximately 14 million pounds. In 4 days, 15 hours, and 29 minutes, all of those parts were assembled into a functioning vessel. On November 12, 1942, less than 5 days after the keel laying, the SS Robert E. Peary was launched into the water. These record-breaking ships became publicity events and propaganda tools. The Maritime Commission and the shipyards understood the psychological and political value of demonstrating American industrial might. The records were carefully orchestrated and documented. Photographers and newsreel cameras captured the dramatic moments of launch. The achievements were trumpeted to the American public as proof of American capability and determination. It is important to understand that these record times were somewhat artificial. The ships launched in record time were not fully completed vessels. After launching, significant additional work needed to be done. Interiors required finishing. Machinery needed testing and calibration. Systems had to be verified. The ship launched in 7 days was a structural hull with basic systems installed. The actual work of creating a seaworthy vessel extended well beyond the official launch date. Nevertheless, the records demonstrated something real and profound. The theoretical limits of shipbuilding production were far higher than anyone had previously believed possible. Even accounting for additional post-launch work, the time required to produce a merchant vessel could be compressed to an extent that conventional wisdom had deemed impossible. By 1943, American shipyards had perfected the Liberty ship production process. The average construction time had compressed from the Patrick Henry's original 150 days to approximately 42 days. This represented a remarkable improvement in efficiency and speed. The yards were not working in isolation. They shared information, learned from each other's innovations, and continuously refined their methods. The peak of production came in 1943. At this point, American shipyards were launching 3 Liberty ships per day on average. 3 ships every single day, rolling out of the yards and into the water. This represented an annual production rate of approximately 1,000 ships per year. The output was being distributed across 18 shipyards, located in 13 states across the United States. The individual yards began to develop their own specializations and innovations. The Permanente yards in Richmond, California, became renowned for their prefabrication techniques. The Bethlehem Fairfield yards in Baltimore pioneered certain welding methods. Federal Shipbuilding in Kearney, New Jersey, developed innovations in scheduling and material flow. Each yard was slightly different, yet all were producing Liberty ships to the same basic design. The workforce expanded dramatically. One North Carolina shipyard alone employed over 20,000 workers at its peak. These workers came from every background imaginable. There were experienced shipbuilders who had worked in yards for decades. There were farmers who had never been in an industrial setting before. There were recent immigrants seeking opportunity in American industry. Increasingly, there were women. The entry of women into shipyards represented a social transformation as significant as the industrial transformation. Welders, riveters, electricians, painters, and general laborers, women performed all these tasks. Women comprised approximately 30% of the shipyard workforce at some facilities. Many women had never worked in industry before. They had come from homes, schools, and small towns. The shipyards trained them, sometimes in intensive programs lasting only days or weeks, and put them to work. The women who worked in Liberty ship construction became symbols of American mobilization for war. They balanced the demands of wartime work with family responsibilities. Many worked 10-hour shifts, 6 days a week. The wages were better than most jobs available to women at the time. The work was meaningful. They were directly contributing to the war effort, building the ships that would carry supplies to the Allies. Their participation was celebrated in newspapers and magazines as an expression of American determination. The ships themselves received names that reflected American history and values. The Liberty ship design meant that hundreds would be built, far more than traditional warships. This created an opportunity to name vessels after a much broader range of American heroes and historical figures than was traditional. The signatories of the Declaration of Independence were honored first. 17 Liberty ships bore their names. Other vessels were named after American authors, scientists, military leaders, and historical figures. Some ships were named after cities and counties that had purchased war bonds. Organizations could propose ship names if they had raised sufficient funds through bond drives. Thus, Liberty ships carried names like the SS Jack London, honoring the American writer, and the SS Grange, honoring the Farmers' Grange organization. Notably, 17 Liberty ships were named after prominent African Americans, recognizing the contributions of Black Americans to the nation's development. The first was the SS Booker T. Washington, launched in 1942. The christening ceremony was performed by Marian Anderson, the renowned opera singer whose right to perform had been denied at Constitution Hall in Washington, D.C. 3 years earlier due to her race. That Anderson would christen a ship bearing the name of one of America's great African-American educators was laden with symbolic meaning. A Liberty ship cost approximately $2 million to build in 1945. This price encompassed all the steel, components, machinery, labor, and overhead associated with construction. It was an extraordinary value, a fully functional merchant vessel capable of carrying significant cargo across the world's oceans for merely $2 million. For comparison, a single military cargo aircraft cost roughly $3 million and could carry a fraction of the cargo. Each Liberty ship carried a crew of between 38 and 62 civilian merchant sailors. These were the men who would actually operate the vessel, navigate the oceans, manage the cargo, and maintain the ship's systems. They would also carry between 21 and 40 naval personnel whose purpose was to operate defensive guns and communications equipment. The civilian merchant sailors were not military, but they would face the same dangers as military personnel: submarine attacks, aircraft, mines, and the storms of the Atlantic. A Liberty ship was designed to carry 10,000 long tons of cargo. This represented its official capacity. However, during wartime, the vessels routinely carried far more. They were overloaded with cargo deemed essential to the war effort. Every cubic foot of space was utilized. Every ton of capacity was filled. The ships would ride low in the water, heavily burdened, crossing the Atlantic and Pacific through waters filled with danger. By 1943, it was becoming clear that the Liberty ship design, while adequate, had limitations. The vessels were too slow for some purposes and too small for optimal efficiency. A superior design was being developed: the Victory ship. The Victory was somewhat larger and notably faster. The Victory would eventually supplement the Liberty in the American merchant fleet, but the Liberty ship remained the workhorse of the effort. The production system that had developed was a marvel of industrial organization. Raw steel was procured from mills across America. Component manufacturers built engines, turbines, electrical systems, and thousands of smaller parts. Suppliers provided everything from rivets to rope to paint. The materials flowed into the shipyards through carefully coordinated supply chains. The scheduling systems ensured that the right materials arrived at the right time for assembly into complete sections. The completed sections moved through the yards on predetermined schedules. Workers performed their assigned tasks with practiced efficiency. What had been created was not merely a collection of shipyards. It was a system. It was an industrial ecosystem that transformed raw materials and human labor into finished merchant vessels at a pace that still seems remarkable more than 80 years later. The competition between yards, the innovation at individual facilities, and the sharing of knowledge across the industry created an environment of continuous improvement. Every month, the yards found ways to work faster and more efficiently. Every month, the record times for ship construction fell further. Part 4. The Cost and the Legacy. When the Second World War ended in 1945, American shipyards tallied their achievement. Between September 1941, when the Patrick Henry was launched, and the final months of 1945, 18 American shipyards had built 2,710 Liberty ships. The number seems almost abstract when stated plainly. 2,710 cargo vessels, each one a complete, functional ship capable of crossing the world's oceans and carrying essential supplies. The scope of the accomplishment was difficult to comprehend. At the peak of production in 1943, the United States was delivering nearly 800,000 tons of cargo ship capacity per month. This represented a staggering amount of industrial output. To place this in perspective, The average merchant shipbuilding rate during the 1930s, in peacetime, had been less than 100,000 tons per month across the entire world. In 1943, the United States alone was producing nearly 8 times that rate. American shipbuilding capacity had increased by a factor of roughly 70 compared to pre-war levels. For a brief moment in history, the United States was responsible for nearly 90% of worldwide shipbuilding. American yards were producing ships faster than any other nation on Earth could produce anything. The entire industrial capacity of the world's greatest shipbuilding nations combined could not match what American yards were achieving. The strategic equation at the heart of the Battle of the Atlantic was brutal and mathematical. Germany was building submarines, fast, deadly U-boats that could sink merchant vessels with devastating efficiency. The submarines were weapons of war, complex machines requiring skilled engineers, scarce materials, and considerable time to construct. Germany built approximately 250 U-boats during the entire course of the war, but America was building cargo ships, thousands of them. Each Liberty ship took perhaps 40 to 50 days to construct at peak efficiency. A U-boat took roughly 1 year to build. The mathematics were inexorable. For every U-boat Germany produced, America could build roughly 8 Liberty ships. Germany could sink merchant vessels, but not faster than America could build them. By 1943, the tide of the Battle of the Atlantic had turned. The submarines were still dangerous, still taking lives, still sinking ships. But they could no longer win the war through starvation blockade. There were simply too many ships. The cost in human lives was profound and often overlooked. The merchant marine, the civilian sailors who crewed the Liberty ships, suffered terrible casualties. 1 in every 26 merchant mariners died during the war. This mortality rate was higher than that of any branch of the armed forces. No other group of Americans faced greater danger in proportion to their numbers. The merchant sailors faced the same hazards as military personnel, but without the same recognition or benefits. They experienced submarine attacks, watched their ships sink, endured exposure in lifeboats and life rafts, suffered wounds and disease, and sometimes perished in the cold waters of the Atlantic. Yet their sacrifice was less celebrated, their service less recognized, their losses less mourned than those of military personnel. The Liberty ships carried almost everything needed for the Allies to fight and ultimately to win the war. In the European theater, Liberty ships brought ammunition from American factories to European ports. They carried fuel oil to power ships, vehicles, and industry. They transported food, millions of tons of provisions to feed armies and populations. They carried cigarettes, which were valuable trading goods in occupied and liberated territories. They hauled jeeps, trucks, tanks, and aircraft. They even carried supplies as mundane as toilet paper and as critical as plasma for battlefield surgery. In the Pacific theater, the distances were even greater. Liberty ships traveled to island bases, carrying supplies to support the American island-hopping campaign. They delivered the materials needed to build and sustain military installations across the vast Pacific Ocean. Without the Liberty ships, the American military campaigns would have been impossible. The logistics of modern industrial warfare, the requirement to supply distant armies with vast quantities of material, could not be sustained without merchant shipping. The production of Liberty ships represented a triumph of industrial organization and human determination. But the ships themselves exposed technical vulnerabilities that would have lasting consequences for maritime engineering. The welded construction of Liberty ships, revolutionary for its speed and economy, had an unforeseen flaw that emerged slowly and ominously. In the cold waters of the North Atlantic, some Liberty ships developed cracks in their welded hulls. These cracks appeared spontaneously, sometimes catastrophically spreading through the structure of the ship. The phenomenon was termed brittle fracture. Brittle fracture is a metallurgical phenomenon in which steel, under certain conditions of temperature and stress, loses its normal ductility and becomes brittle like glass. When brittle fracture occurs in a riveted hull, the riveted seams act as barriers that arrest the propagation of cracks. The crack reaches a rivet hole and stops. In a welded hull, there are no such barriers. A crack can propagate continuously across the entire length of a weld, spreading through multiple welded seams, potentially splitting the entire ship in half. The first instances of serious brittle fracture in Liberty ships occurred in 1943. Ships began to develop cracks while at sea. Some cracks were discovered, and the ships were diverted to ports for repair. Other cracks went undetected until catastrophic failure occurred. 19 Liberty ships actually broke in half from brittle fracture. The ships simply snapped apart in the cold Atlantic waters, spilling their cargo and crews into the sea. Nearly 1,500 incidents of significant brittle fractures were recorded in Liberty ships during and after the war. The problem became a matter of urgent concern for maritime engineers and metallurgists. Investigations determined that the issue stemmed from several factors. The steel used in the Liberty ships, while adequate for normal conditions, became brittle at very low temperatures. The welding process, as performed during high-speed wartime production, sometimes introduced weaknesses in the welds themselves. The rapid cooling of welded steel created stress concentrations. The design of the hull, with concentrated stresses at certain points, could trigger fracture initiation. The response was multifaceted. Welding techniques were refined. Quality control in the welding process was improved. Steel specifications were changed to specify higher quality material less prone to brittleness. Ship routing procedures were modified. Whenever possible, Liberty ships were routed through warmer waters where brittle fracture was less likely. The ships that had to traverse the cold North Atlantic were inspected more frequently and monitored more carefully. The technical problem was not solved completely during the war, but it was managed sufficiently that the Liberty ships could continue to fulfill their mission. The casualty rate from structural failure declined after 1943 as knowledge about the problem spread and countermeasures were implemented. The brittle fracture problem, while tragic in its consequences, drove important advances in metallurgical science. The investigation of the phenomenon led to better understanding of steel behavior at low temperatures. The work done by engineers and metallurgists studying Liberty ship fractures contributed to advances in welding technology that persisted for decades. Many of the safety standards for welded structures that exist today were developed or refined in response to problems encountered in Liberty ships. After the war, most Liberty ships were scrapped. The design had been optimized for emergency wartime production, not for longevity. The vessels had served their purpose. They had carried supplies across dangerous oceans during the crisis of World War. Once that crisis had passed, most of the ships were surplus to requirements. Some Liberty ships were converted to other uses. A few became hospital ships, equipped to carry wounded personnel. Others were converted into troop transports. Some were sold or transferred to other nations. A small number continued as merchant vessels in peacetime service, operating for years or even decades after the war. But the vast majority were sold for scrap metal. The steel that had been urgently assembled into ships was melted down and returned to the industrial cycle, to be made into something else. Today, only 3 Liberty ships remain afloat. The SS John W. Brown, launched in 1942, is maintained as a museum ship and is occasionally placed in service for short voyages. The SS Jeremiah O'Brien, launched in 1943, is similarly maintained as a museum vessel. A third Liberty ship, the SS Stephen R. Jones, is also preserved. These three vessels are kept in commission specifically so that people can walk their decks, experience the tight quarters of a merchant vessel, and understand what it meant to sail across the Atlantic in wartime. Walking through a Liberty ship today, visitors encounter the reality of merchant service. The crew spaces are cramped. The vessel pitches and rolls in heavy seas. The accommodations are Spartan. The work of maintaining and operating the ship is constant and demanding. Modern visitors can grasp, in a way that statistics cannot convey, the courage required of merchant sailors who crossed the Atlantic in these vessels, knowing that German submarines prowled the waters and that disaster could strike at any moment. The Liberty Ship program left a legacy far beyond the ships themselves. The methods pioneered in Liberty ship construction influenced shipbuilding practices for decades. Prefabrication, assembly line production, and welded construction became standard in maritime industry. The innovations in production management and logistics were adopted by other industries. American manufacturing learned lessons from the Liberty ship effort that influenced everything from automobile production to aerospace manufacturing. The program demonstrated the power of industrial mobilization. When a democratic society commits its resources to a goal and organizes them systematically, extraordinary achievements become possible. The Liberty ships proved that speed and quality need not be enemies. Through innovation in design, manufacturing process, and workforce organization, both could be achieved simultaneously. The Liberty ship was not the most elegant vessel ever built. It was not the fastest or the largest. It was not revolutionary in design. What the Liberty ship represented was something far more powerful: the application of American industrial genius to a problem that threatened the survival of free civilization. The ships were built by Americans of every background and circumstance. They were captained by experienced merchant sailors. They carried supplies across oceans of danger. Many did not complete their final voyages. Some rest on the bottom of the Atlantic Ocean, monuments to sacrifice and service. When the Second World War ended, the Liberty ships stood as monuments to what a free industrial society could accomplish when mobilized for survival. At the peak of crisis, when the outcome seemed uncertain and the challenges appeared insurmountable, America had built a ship almost every day for nearly 5 years. The Liberty ship was the bridge that allowed the Allies to sustain their fight and ultimately to win. It was a triumph of human ingenuity, determination, and industrial might, a floating testimony to what becomes possible when a free people unite in common purpose.